Hello everyone, welcome back to my channel. I am Vihan, a perfect AB Precal 5 kid. I took the test when I was in 9th grade and I got a perfect 5. I am currently in 11th grade and I have started this video series since last year. Now I know that College Board does not give out the official multiple choice practice of AP Precal, and I was one of the first kids to have sat for this test the first time it was introduced. So I know exactly what questions they asked me on my multiple choice. So although I have made these questions on my own, I can guarantee you that these are very much relevant to your test. I have a total of 35 questions with me and I'll be having them in 5 videos of 7 questions each. So if you like the videos and if you feel that you want to look at all 35 of them, make sure that you watch all 5 videos. Apart from that, the entire 35 question PDF along with the answer key is linked in the description below. If you do choose to directly go to the PDF instead of looking at the video, I would really appreciate if you leave a like or a comment. It would really help me since I'm applying to college as well. Yeah, so let's begin. Alright, question number 15, have a try. Now, if I'm being honest with you, I don't think 15 or 16 are the closest questions which can be asked on your AP Precal test. Like when I gave my test, I don't exactly recall what AP I was asked or what GP I was asked. So I'm trying to be as relevant as possible. So in case if you don't understand this, or just keep in mind that this isn't something which will come sure shot. It's just something to practice, yeah. So question 15, we have an arithmetic. The sum is given by this expression and we have to find the common difference. Now if you notice here, S2, which is the sum of the first two terms, minus S1 is essentially A2 plus A1 minus A1, yeah, which is equal to A2. But A2 is A1 plus D and A1 is just S1. So this is S1 plus D. Yeah. So finally we have S2 minus S1 is equal to S1 plus D. Yeah. Now what is S2? S2 is 3 into 2 square minus 2, which is 12 minus 2, 10. This is S2. And S1 is 3 into 1 square minus 1, which is 2. Yeah. So this should be 10 minus 2 is equal to 2 plus D, yeah, which is 8 is equal to, yikes, 8 is equal to 2 plus D, and this implies that 6 is equal to the common difference, yeah. So option C is your correct answer. Question 16, again similarly like the 15th one, I'm not sure whether it can be asked or cannot be asked, but nonetheless we'll solve it. So we have a GP where the third term is 18 and the sixth term is 2 over 3, yeah. So sixth term is a into r to the power 5 is equal to 2 over 3, and third term is 18 implies a into r square is equal to 18. Now if I divide both the equations, I get r cube is equal to 1 over 27, which implies r is equal to 1 over 3. We have the common ratio, but we need the value of the first term. So if I pick this equation, I have a into 1 over 3 square is equal to 18, which implies a is equal to 18 into 9, which implies a is equal to 162. So the correct answer is option D. The only thing for you to remember is that the nth term of the GP is given by a into r to the power n minus 1. Yeah, awesome. Alright, question 17, have a go at it. Questions like these are bound to appear on your test, so make sure you understand this. Now I'm assuming that at this point, where you're only like a week away from the test, you're comfortable with your log rules. So I'll just walk through the solution instead of explaining much, and I hope you understand it. So log square root 9 over 8 is simply half log 9 over 8, yeah. but then log 9 over it is simply half into log 9 minus log 8, yeah, but log 9 is half into log 3 square minus log 2 to the power 3, yeah, but then this is equal to half into 2 log 3 minus 3 log 2, and now we know what log 3 and log 2 are. Log 3 is q and log 2 is p. Make sure you have them correctly. So this is 2q minus 3p over 2. 2q minus 3p over 2, yes, option A should be it. This one isn't it, this one isn't it, and this one isn't it. So yeah, I hope that was self-explanatory. Alright, number 18. This is a relatively easy one and it can appear on your test. So if you apply yourself properly here, this is a really easy one. You notice the product rule coming in here. So this is basically log base 2 x plus 5 times x minus 1 is equal to 4, and then you have 2 to the power 4 is 16, so x plus 5 into x minus 1 is equal to 16, yeah, and then you expand here, so we have x square minus x plus 5x minus 5 is equal to 16. So we basically have x square plus 4x minus 21 is equal to 0, and then you factor it with whatever you're comfortable with. You can use a quadratic, you can use the middle sum, or whatever you like. You'll basically end up with x plus 7 into x minus 3 equal to 0. But then an important thing here is that you cannot have x is equal to minus 7, yeah, because if you have x equal to minus 7, this part will become log 2 minus 2, but then this is not in the domain. So x equal to minus 7 is not a solution. The only solution is x equal to 3. So might be tempted to look at option C like, hey, minus 7 and 3 and that's it, but that is not what we're looking for. The correct answer is option B, only 3. Question 19, this is likely to appear on your test. Not the exact one, but the same concept of taking the natural log on both sides will come as a question. So again, I'm assuming that you know the logarithm rules, and I'll just walk through the solution, hoping that you'll understand it. So again, the main idea behind these questions is to take the natural logarithm on both sides, and then you apply the rules. So if I take the natural log, I have ln of 5 e to the power 2x minus 1 is equal to ln 30. Now using the product rule, I split ln 5 plus ln e to the power 2x minus 1 is equal to ln 30. Now I subtract ln 5 from both sides and use the power rule here. So I have 2x minus 1 into ln e is equal to ln 30 minus ln 5. Now on the left hand side, notice that ln e is just 1, so 2x minus 1 is equal to, I use the division rule, so this is ln 30 minus ln 5 is ln 30 over 5, which is ln 6, and then I add 1, divide by 2, so I have ln 6 plus 1 over 2. That should be it. Checking my multiple choices, B is the correct one, so 19 is B. I hope that was clear. Alright, question number 20, have a try. Which of the following values of x is not in the solution set of log 3 to x plus 1 is greater than log 9x plus 6? Now you notice different bases here, log 3 and log 9. So your first goal should ideally be using the change of base to get the same base. So I'll do this quickly for you. Log 9 of x, log 9 of x plus 6. If I use the change of base with 3, I get log 3 x plus 6 over log 3 9, but log 3 9 is simply 2, so this is log 3 x plus 6 over 2. I hope you'll keep this in mind. I'll get this out of the way. Yeah. So our inequality is basically log 3 2x plus 1 is greater than log 3 x plus 6 over 2. Yeah. Now if I send this 2 to the other side and I send it to the power, I essentially have log 3 2x plus 1 squared is greater than log 3 x plus 6. I remove the log 3 and I expand, so I have 4x squared plus 1 plus 4x is greater than x plus 6, which leads me to 4x squared plus 3x minus 5 is greater than 0. Now you might be tempted to use the quadratics and the wavy curve. That is again an approach, but if you glance at the multiple choices, yeah, they're very small integers, so I would recommend that you quickly put them in your function. And I notice that if I put x equal to 0, I'll have this thing going to a 0, this thing goes to a 0, and this stays minus 5. So minus 5 greater than 0, this is not something that is true, so x equal to 0 is not in the solution set. Question number 21, find all values of x in this interval that satisfy this expression. Now the non-trivial part is realizing that this is a quadratic equation. So you can start by letting some t is equal to sine x. Yeah. So we have 2t squared plus t minus 1 is equal to 0, and then you can use the quadratic, or you can simply factor, and you'll realize that it is t plus 1 into 2t minus 1 is equal to 0. Yeah. And then you put t back in, then you put sine x back in, so this is sine x plus 1 into 2 sine x minus 1 is equal to 0. Yeah, this gives me sine x should be equal to minus 1, sorry, and this gives me sine x is equal to 1 over 2. Yeah. Now when is sine x equal to minus 1? Well, if we look at the unit circle, sine x is the y coordinate, and the y coordinate is negative 1 at 3 pi over 2. So x is equal to 3 pi over 2 is one solution. Now when is sine x equal to half? Well, sine x is equal to half in two places, one in quadrant 1 and one in quadrant 2. So at this part where it is pi over 6, sine is 1/2, but then sine is positive in the second quadrant as well, which is this angle 5 pi over 6. Sine is half as well. Yeah, so x is pi over 6 and 5 pi over 6. Yeah, looking at my multiple choices, we have pi over 6, 5 pi over 6. We don't have a 3 pi over 2. This one seems correct. Not this one, not this one. So option B is the correct one. What many kids often miss out on is that they'll forget this one. They'll often end up with pi over 6 and 3 pi over 2, but then you have to realize that the sine or the cosine can be positive or negative according to the four quadrants, especially given the domain right here. So the correct answer is option B.